In this video, we're going to be taking a look at an introduction or preview of calculus. We've talked about it a little bit throughout the year, but this is really the first unit where we're going to get really into the idea of calculus. So first of all, there's some definitions, some explanations of the differences between what you've done before and what we're going to be doing now. So let's take a look at answering some of those questions. The first one we're going to talk about is the difference between a tangent and a secant line. So let's look at a secant line first. Now, a secant line is something that you've done in algebra. It's something that you're used to doing. And if we have this curve, we can find the secant line by identifying any 2 points. So let's say there are these 2 points right here. And we're going to draw a line through those. That is your secant line. So a secant line is just 2 points on your line, and your line goes through that. Now, what's important about the secant line is its slope, right? And so you can find the slope by figuring out the change in y over the change in x, right? Now, if we wanted to know, like over here, let's draw another secant line. Now, the slope between those 2 points, the change in y over the change in x, you notice the y doesn't change, so it's just going to be 0. So that would be a slope of 0. All right, so that's what a secant line is. You need 2 points, and you draw your line between those 2 points. That's your secant line. Now, this is what you would do in algebra. Right, you learn to do that in algebra, finding the slope between 2 points, finding the equation y equals mx plus b, and so forth. Okay, that's algebra. Now up here, with the tangent line, this is more along the lines of calculus. And these are some things that we're going to be doing this year. So let's say, for the secant line, we found the point, or the slope between 2 points. With a tangent line, it's the slope at a single point. So right here's that point, and the tangent line touches the graph and then continues. Okay, so like if somebody goes off on a tangent, this is kind of what it means is, hey, they're on the line at one point, but now they just veer off of what they were really supposed to be talking about. Okay, so I know that's not perfect. Let me try to do this again. Let me zoom in a little bit. So you have a single point, and then imagine if you were to draw a line through that point, what would that slope be? So that slope would be like that. Over here, where we drew the secant line, let's put a point at the maximum value. Okay? Now, if we draw a tangent line through that point, it's just going to be a horizontal line. Whereas you notice, this slope is going to be 0. Right? Whereas before we did a secant line with the slope of 0. Now this is a single point. At all of your maxes and mins, your slope's going to be 0. So your tangent line is going to have a slope of 0. So a tangent line is finding the slope at a single point, and that's what we're going to be studying in calculus. And then down here, this is finding the slope at 2 given points on a line. And there's many more real-world applications of single points. It would be like if you're trying to project the speed of a particle, right? You can't look and see, oh, that particle is going this many meters per second. So you have to kind of come up with an equation of its movements, and then you can use that equation in calculus. Say at 10 seconds, how fast was it going? Or at a half a second, how fast was it going versus, 1 second? How fast was it going? Much faster or much slower? Versus between 1 and 0 and 1 seconds on average, how fast? We can say at 1/2 second, this is exactly how fast it was going. So it's very powerful in that regards. And, I just put this up here, solving problems. Understand the problem. This is going to be hugely important, especially as we get into applying some of these concepts that we're going to be learning. Understand the problem, outline your plan, figure out how am I going to solve this, what information do I need or am I going to use to solve this, follow through on your plan, work out the problem, and then does your answer make sense? Always think back, does this answer make sense? And if it doesn't, revisit, go back to understanding the problem. And then describing the difference between tangent line and secant line. Remember that the tangent line, that is more of what we're going to be doing in calculus, right? And that's defining the slope at a single point. Versus here with the secant line, this is more algebra and finding the slope at between 2 points. Well, let's say between 2 points. Okay, so those are the biggest differences between those, and you can look at the graphs above to help with that. So next we're going to talk about area, and we're going to learn how to algebraically find areas under the curve. Areas under the equations and their curves are hugely important in answering real-world problem, and so the more exact your answer is going to be, the better off that it is. For example, medicine, the amount of medicine you're going to give somebody versus their weight, age, all of that, they have their own curve. And you want to make sure the amount of medicine you're giving them, let's say you're an anesthesiologist or a nurse anesthetist, you want to make sure that they're going to stay asleep. So you need to be as precise as possible because you definitely don't want them waking up too soon or going under too far that you can't get them back awake. So you got to keep them in that sweet spot. All right, so different ways that you're going to estimate. So you're going to use rectangles that hit the curve and then go into the curve. So they hit the edge of the curve and then go in, right? And then you can find the area of these. So let's say this is 1, 2, 3, 4, 5. These rectangles all have a length of, or width, however you want to think of it, as 1. So your change in x is 1, right? Now your change in y are these points here. That's where you would have to plug it in. So this is f of 1. This one would be f of 2. And that would be f of 3, f of 4, and so forth. That would be f of 5. Right, so the area, let's say we want to find the area of this one right here. Okay, so if you look at this, it would look like this. This is 1. And this is f of 5, so it would be f of 5 times 1, right? Because your y value would give you that height from there to there, so from there down to there. So you can calculate areas using rectangles and approximation, at least, because you still have this space in between that's left over, so this under here is going to be an underestimate. And then if you do similar rectangles on this side, let's use rectangles like this, right, where our rectangles go outside of that curve, but they're still hitting the edge. So our heights are still defined, like this height right here is still defined by that. So the 1, 2, 3, 4. So if we wanted to find the area of this one right here, it would look like this. So this would be a distance of 1, because from there to there is just 1. And this would be f of 4, because the distance from here, which is this point right here, down to there, down to your x-axis, is f of 4. So that would be f of 4 times the width, which is 1. And you would do that for all of them. So it would be f of 3 times 1, f of 2 times 1, f of 1 times 1, to find all of those heights. And you notice on these are a little outside. So this one being an example of when you would have an overestimate. Putting those rectangles in there to approximate the area. And that's pretty much it for this video. The other thing I want you to look at, pages 63 and 64. Chances are we'll hopefully talk about those in class. But on 63, 64, they have problems that you can solve with without calculus, so that'd be using algebra, everything you know up to this point. And then in the other column, they have problems that you would need calculus to solve, and you can see the complexities of the problems that you can solve with calculus versus without, right? And it's hugely important because we're in a changing world, so being able to use change to solve problems is really important, and that's all calculus means. It's the study of change, okay? So that's it for these notes. These are your 2.1 notes, a preview of calculus.